I haven't uploaded in 3.5 years because I've been busy learning nerd stuff, such mostly mathematics. This is an integral problem I made about 10 minutes ago, and it basically asks us to find the area under the curve for this function between the boundaries of x is -1 and x is 3. And to do that, the first thing we need to do is think about what that looks like as a curve. I've put it in my calculator already. The way we do this is factor theorem. So factors of 40 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, and plus or minus 40. Now, we check each one individually in the calculator. Boom. So p of 1 is a factor, equals 0, therefore x minus 1 is a factor. And now we plug in x minus 1 to check. It is not a factor. Try 2. It is not a factor. Try minus 2. It is. So p of minus 2 is a factor. Therefore, x plus 2 is a factor as well. Now we try 4. It is a factor. So p of 4 equals 0. Therefore, x minus 4 is 0. Minus 4 is not a factor. And now we try 5. Not a factor. Minus 5 is a factor. So now we have our 4 factors for the polynomial. And now we can graph what it looks like. So rough sketch is fine. We don't need it to be to scale. We just need to know the shape of it. So we have +1, -2, +4, and -5. These are all x-intercepts. Excuse the poor graphing. And key point would be -1 and +3 because those are our bounds. The y-intercept is at 40. So the graph should look something like this, going up and down like that. Something like that. So the boundary for this graph is about here. Therefore, the area we are concerned with is this part and this part. Integrals deal with a signed area, so we can't just take -1 to 3. We have to split it up into this part, this positive part, and this negative part, because positive above x-axis, negative below x-axis. To do that, we can apply a special integral property, whereby we can do integral of -1 to 1, because that is x is -1, that is an intercept, and that is where it goes from positive to negative. And just using shorthand, we can just do f of x, just for simplicity, of x dx, plus integral from 1 to 3, because that is 3 and that's 1, same function, d of x, and that will give us our area. Now, f of x is this one above. Next step is to find the antiderivative, or the primitive, of this one. And now we just apply basic integration, being, so that gives us capital F of x equals to, what, 5? X to the power of 5 on 5 plus 2x to the 4 on 4 unsimplified minus 21x cubed on 3 minus 22x squared on 2. These can all be simplified, plus 40x. And we don't need a plus c, as we usually would for indefinites, because this is a definite integral. And now simplifying this, we've got x to the 5 on 5 plus a half x quartic minus 7x cubed minus 11x squared plus 40x. And now the formula becomes this. F of x from -1 to 1 plus this. 1 to 3. And now, how that works is we can split up this as such. Sorry, this is equal to f, like primitive of 1 minus primitive of minus 1. Now we do that for the first one, so our primitive was answer a to the power of 5 on 5 minus plus a half, answer to the power of 4 minus 7 answer cubed. Was it minus 6? It was minus 11 answer squared plus 40 answer. And now we just plug in 1 and minus 1. So 1 into this, double checking I got it right. Should be fine. So we got 22.7. Yep, that's fine. So we've got 22.7. Now I've got minus 1. Putting that in there, we've got plus 43.7. And now for the second part, capital F of x for 1 to 3. We do the same thing, but for f of 3 minus f of 1. And now we know f of 1 is 22.7. Now we need f of 3. So that is minus 78.9. So they've got minus 78.9 plus minus. So, minus 78.9 minus 22.7. And now summing this up, we've got 22.7, 7, plus 43.7, plus, actually it's minus 78.9 minus 22.7. And that gives us 35.2, which minus 35.2, sorry. And that is our answer. That is our area under the curve for a given function.